Hello everybody, my name is Sylvain Rochon and I'm getting people to expand their human experience using cutting-edge technology. Today we'll be talking about, well, how we can make electricity and hydrogen both using solar energy. This is something, it's based on a single article that I received, I think, last week. But I've been accumulating a lot of energy innovation articles for a while. So it's been a while since I've talked about energy, except for, I believe I talked about solar energy not long ago. Because I'm a big fan of solar. I'm a big fan of renewable energies. Not because of environmental or the ecology so much, although that's a really good thing. But because we need to, towards the future, we need to have infinite amounts of energy. We need to be able to harness things that are at a solar system level. And that means we need to harness some basic atoms like hydrogen, and we need to harness photons, the sun, because it's all over the place, and we can't run out of it. And also, there's all these systems with hydrogen and the sun where you can recuperate it in many ways. It's just a smarter move, and the fact that we can make it extremely ecological is just a humongous bonus. Fossil fuels are really old school, guys. It's coal and gasoline. These things they run their course. Now we have to move on to better things. And the reason why we are capable of doing it now is because we're able to find ways to make it in a friendlier way and also a cost-effective way, as well as efficient. And that took a while for us to get to where we are now. Now, this team out of UCLA specifically, they created this particular combination of supercapacitor and fuel cell, where they have small modules. It's experimental. It's not really deployed just yet. But in essence, it's built off of very cheap materials. The metals that are typically used to convert solar to electricity or to using solar to make hydrogen are catalysts that are pretty heavy, polluting, or expensive, like palladium, platinum, gallium, which is very nasty for the environment, and also, poison. And those are cool, and we're still tinkering with those. And I'm mentioning a few in the blog as a prelude for this one. But this particular one that we're using cobalt, nickel, iron. These are the metals that are being used, as well as, of course, some elements of plastic, silicon, and whatever else that's in there. The organic type of atoms. Not organic, non-metals, if you remember your chemistry. So all fairly cheap material. They're just combined in a very innovative ways. And what's pretty cool is that you have your sun that comes in, and you have access to water, so the humidity for the air, or it could be fed in. The article is not that explicit, but you feed in water in some way, and the element or the item the UCLA researchers created converts the sun to electricity a little bit like a solar cell would, but also what it does is that it does split the water into hydrogen and oxygen, and it retained the hydrogen into a fuel cell. And as you know, fuel cells on their own are a form of battery, if you will, and you can generate the electricity from that. So it's actually, there's a little bit of a cycle going on in the unit, and that makes it really interesting and very versatile. So if you don't have all the elements in place, or you have more need for power, you can use, like, the fuel cell is going to be to punch it. The supercapacitor is going to be able to punch it in a different way to give you some electricity and some energy more in a very immediate, very strong way, but in one shot. Fuel cell is more, usually gives out the electricity in a more gradual way. So it generates its own hydrogen by the reaction with the water and the sun, and then there's this capacitor slash battery fuel cell kind of a thing going where you can generate electricity in a different way. It's really, really cool stuff. And I'm really happy to see these innovators thinking about very cool ways to combine different technologies into a single unit. Because I'm always, as an engineer, I'm always thinking about how do you deploy this. I'm always encouraging entrepreneurs to look at these researchers and potentially invest in these for deployment. You can imagine, the sun is always around at least, every day it's there to a certain degree for a number of hours. And water is readily available, even though it's not pure. It doesn't need to be pure for these kind of processes. But then you're generating all sorts of different types of mechanisms for energy that could be used in the home. So I'm always thinking about these units that can be used for businesses or individual homes. I really like the idea of decentralized energy distribution. If every home can make its own energy, and also in the previous video, I think I was talking about making its own water, for example, things like that. Then you're leveraging modern technology in the home. It's easy to manipulate. It's probably easy to install and maintain. The materials are not expensive. They're not toxic, so you can touch them and fix them probably yourself by changing off modules, just like by going to your hardware store, for example, and things like that. The amount of efficiency you're gaining by making your own electricity at home using units like this versus the centralized way of that we generate the electricity. There's a huge loss of energy that we have by going through from the power plant to a home like what we're currently used to. It's amazing. It's incredible. So and hydrogen as a gas, if you can find novel and better ways to get hydrogen as an energy source, like what certain cars are doing and certain manufacturers are doing right now, that gas per kilo is at least twice more efficient than gasoline energy-wise, per kilo. And when you burn it, you generate water, pure water, which can be using the sun. And some of these techniques that I wrote about in my blog can be reconverted into hydrogen and oxygen. Oxygen is good, of course. Hydrogen, well, you use it to burn it again. And all you need is to harness the sun in a certain way using certain materials and modules to do it. And that's wonderful. It's beautiful for everybody. It's useful. People can manipulate, like individuals that are not engineers or scientists. Once they have the modules in hand, they can manipulate it on their own. No problem. It's probably quite light because of the materials involved. Iron is probably the heaviest that I've read about. The three metals that I mentioned, actually, the cobalt, I believe, is lighter than iron. I don't remember the periodic table all that in that amount of detail. But anyhow, great stuff. But also something that I mentioned in my blog is not about hydrogen, but a couple of really interesting other sources of energy that are infinite, I guess, is one way to describe it. It's not really infinite, perpetual. Okay, and the one that is the most exciting is what some researchers have figured out about graphene. Graphene is a monolayer of atoms. It's like a sheet of carbon atoms. Okay, a single atom wide, so it's definitely like a sheet, and it has very interesting properties. And what's really interesting here is that they figured out, looking at it at a nanoscale, this sheet is not like straight and rigid. It's actually a little bit like cloth, if you will. So it kind of undulates on its own just because of vibrations with the carbon atoms. They're never static because they have electrons spinning around them, and so you have a sheet that's kind of wavy. like the surface of water. And what they decided to do to see if they could harness some electricity off of this and how much is that they put a couple of electrodes in on top and the bottom of the graphene sheet, and then as the sheet undulates, it touches one pole and then the other pole, kind of going like this in a wave, and it generates tiny amount of electricity per square centimeter, but it's enough to run something like a watch. Or you can imagine at a smaller scale, because we're talking about a sheet that's an atom wide, an atom thick, so sorry. If you have a very small sheet and a very small device that requires electricity, you can have these little devices fixed into nanobots, for example, or nano machines, and it'll generate electricity on its own. Because this is just based off the movement, the natural movement of the atoms that are just waving on their own. There's no energy that needs to be input in there. It's just because they're room temperature. There's a certain, as atoms are warmer, they tend to vibrate more. So maybe the waves are a bit stronger and bigger when it's a bit hotter. But as long as you're far away from absolute zero, things are moving, and you're harnessing nano electricity, and that's enough for small items like. I'm thinking about nanobots really like crawling inside our veins to fix our cells and to do all sorts of these things inside the body. And you can use these little devices based off of graphene and electrodes. And it will be constantly fed, the nanobots, constantly fed with electricity that it needs to do its job. You don't need any batteries in there. You don't need to charge them. You don't need them to feed it. To get any other sort of electricity. It's all integrated inside this little device. And this is absolutely vital for when we develop a little bit more into the nanomachine world and we need a power source. Well, let's use that. That's awesome. It's not invasive, it's not trouble, it's not poisonous, it's carbon. And you just create these little tiny electrical motors, if you will, out of graphene electrodes, and you apply them to whatever device you need and you want, and you have electricity and locomotion, and that means it can operate and to do whatever it needs to do. So I'm pretty excited about advancements in energy generation in general, but in particular, I really love hydrogen as a combustible energy source. Very powerful, strong energy source, and then we have electricity, which is more stable and long duration type of energy source, and you can have that based off solar energy directly and through a lot of different means that I've talked about in different processes and equipment that I've talked about in previous videos. And then at the tiniest scale, we have these potential tiny generators that don't require sun or anything whatsoever. They can run in perpetuity, which is absolutely fantastic. Anyway, that's all the reporting I wanted to do on that today. I hope you enjoyed it, and I'm looking forward to make another one, I believe next week, which will be my last one in a while because I'm receiving a visitor for about a couple of weeks. So I'll be doing the next one next week on some subject, maybe nanotechnology, since I'm a bit inspired. We'll see. And then I'll be off for a couple of weeks, and I may yet do some video, but it probably will be less complicated. Anyway, that's it for now. I wish you a good week, and I hope you had a great Thanksgiving. Ciao for now.